About Docker and Kubernetes. So in this session, we try to understand, explore what is Docker and what are the course content and how we are going to learn this course. That is just like a intro about Docker and Kubernetes. So it's a free webinar. Anyone can join. Anyone can invite to this meeting. Yeah. So once you're understood what is our content and you are fine with that, you can commit and you can inform to Shailaja so that we can proceed on that one. Yeah. So in this Docker and Kubernetes, Docker is a technology that allows us applications to run inside the containers. So what is this container? Why we are using this one? What's the speciality? So when you're going to work on the normal machines, Linux machines, they are going to have highly capabilities and then more stable. So containers, most of the containers, we're going to use Linux containers, Linux platform inside that one. So these containers, they're going to run some services. So it may be prepared in one of the language. It may be Java program, it may be .NET, it may be Python, it may be Node.js, any language. They can use it to serve purpose of that one. Okay, so one particular task is one small thing. If you take add two numbers, that is also become a service. So if you take e-commerce website and we want billing, that billing is a service. Catalog is a service. Product catalog we can make and we can add into database. That is one of the service. So like that, we can take anything as a task that we can convert into program. That program can be stored into container and that will be giving a service. Okay, so what is that? How it happens? I will keep on exploring so that you can understand much more deeper level. So what is this Kubernetes? So Kubernetes, it is a coordinate, it is a mediating between the multiple containers. You know containers now, and you just if you have 10 containers, how it is going to work? If you want a live environment, production environment, what we need, if one container goes off and another container still continue work, business should not stop. So that is the main reason we are always look for a cluster configurations. So cluster configuration capabilities are there in Kubernetes. So cluster of containers. So if the expansion is a most important thing, or scaling is one of the important thing which is required for businesses. That is we are going to provide with these two important technologies. If we are using these two combination, then it is a CNCF concept. What is that CNCF? We'll come to that one later on. But yeah, so when you're building most of the cloud platform base microservices applications, then this is one of the growing technology, Docker and Kubernetes. So how this is started and who is I'm talking to you guys. I'm Pavan Bhavani Shekhar, and I have experience around 20 plus years of experience in IT, and I'm teaching this one since online in online middleware technologies and self-scripting, automations, Python since 2013 onwards. And yeah, most of them are on cloud platforms, AWS, GCP, Azure Cloud. So these are the platforms which I'm using to explore things and teaching. So I have one blog, technical blog that is related to DevOps and DevOps Hunter blogspot.com. You can see, and in Google you can find that one. So DevOps and Hunter, two words. If you combinedly search, you will get my blog. And middlewareadmin.net, that is another website which is old one. And yeah, right now people are not much using middleware, but still some of the projects are still there working with the middleware. Yeah, so Python is the most common programming language which will be used in middleware. It will be used in developing programs. So basic programming. When I started, I have prepared this blog also. So that's about my intro. Okay, so what is the problem it is going to solve from Docker? So it works on my system. This is a common problem. So developers develops code and they know what is required, what library required, what is a setting required. They runs in their system, and but when it goes to the testing part, it doesn't work. So this is the main problem, and to solve this one, Docker came into the market. Okay, so how it is going to work? What is the situation? So this is a situation where developer is going to say it works on my system, and if this goes to the testing part, he's going to get some problems or errors, or the code is not working. So why it is not working and what is the solution? There are two solutions. So we can have the same thing what developer is having. So that same package, if you do the machine, entire machine, we don't do step by step what is he made. So instead of doing that one, so we can have a virtualization concept. So same virtualization concept, packaging of your virtual machine, that is possible using Vagrant, using VirtualBox, using VMware. So these are all different technologies which help us to pack the VMs, but it is very huge. But that was the first solution they came up, and the problem can be solved with this one. But it takes longer time to bring up one machine. What developer is having the same thing. If you want to make in other environments, test environments, QA environments, stage environments. So these are the different environments where you are going to work. Okay, so host machines you're going to have, and virtual machines. There are two types of machines. So you know Oracle virtual machine that is providing this capability, and also VMware that is also providing same kind of thing. But VMware is commercial. You need to get the license, and you have to use the VM manager. Here Oracle virtual machine, that is VirtualBox, which we can install it on our local system on laptops, and we can work on multiple missions. One mission you can use Ubuntu, another one you can use CentOS, you can use Rocky 8. So like that you can create, and you can see whenever you want, you can bring it up, and you don't want, you can bring down, halt it. So these are the capabilities which helps us using the virtualization concept to make same as developer is having. And it saves some part of situations, and it gives some of the solution. It's not full-fledged solution. Okay, so coming to our containerization, how it started. So when you have a Linux operating system, we want to understand the problem clearly. Okay, so user is working on a Linux system. Every project is working on most of the common Linux kernels. Okay, and it is on operating system, and it is runs on one key area, that is we are going to call it as kernel, and user is running his application in user space. So these are the three areas where we are going to have this is a common thing required to run every service, run every application, Java application or Node.js application, .NET application, anything you take, it will works on this. Okay, so the problem is if you have the same structure, you can run on every system same. But the thing is, what kernel enhanced libraries the user is using in development, that is changing, varying. Okay, so when you see this problem, if you go for Windows, it is different. If you go for Linux, Red Hat, it is different. Ubuntu, it is different. So everyone is having their own covers, their own labels on top of theirs. So Windows right now, Windows 10 onwards, we are having emulated Linux capability. So this is made to run faster and bring it up as a VM, bring it up as a container. So this is a capability added in the Windows also. So if you make everything common similar, then best solution we can come up with the containerization. So you can run container in any one of these OSs. Okay, so the user space will be same and easy to handle the microservices. So you can run a microservice on Linux kernel, Red Hat, Ubuntu, or even in Windows also. So that is a solution. We got it from Docker. So first, initially, Docker focused on Linux. And next, they started working on Windows, Mac also. So when you're working on a Windows system, Docker on desktop we have to install. When you're working on Mac also, Docker on desktop will work. So the softwares are again different. Docker softwares are developed later after Linux one. So first they focused on Linux Docker wrapper. After that, this one. So that is how the solution came up, and it is giving very good results in developing the SDLC. The SDLC pattern changed and everyone moving towards agile pattern, DevOps agile patterns. And so quickly you can bring it up one Linux container. So when you use the Docker, it is going to bring up in fraction of seconds once the image is available on the same machine. Linux kernel is a requirement. The basic requirement is kernel. Linux kernel should be there, then you can bring up the container. So the commonality is this Linux kernel user space should be available. Then you can run your containers. So that is a solution we are getting from the Docker. You can run various containers for each microservice. You can run one microservice on Windows, another microservice you can run on Red Hat Linux. You can do integration, connection. So that is possible in Docker. Okay, so Docker images and containers, we just give a high-level brief intro. So when you're going to have this Docker, when you're running Docker microservices, what it's going to work, how it is going to work. So images, you're going to have bigger in size, and you can take, for example, you want to run a Tomcat server. Tomcat is one image. Tomcat image you have to download and bring it into your system. Then you can run number of containers. Okay, so Tomcat container 1, container 2, container 3, like that you can create, and every container feels like it is having the 1 GB space for it. So this is how it is going to create. So run image is a simple process, then that will brings up the microservices available in these containers. Until that, this is image is sleeping, so it is not in active state. So when it is active, that is running. So running means that is a container. Okay, so to run, we are going to use a Docker run command. So how to use that one, I will see in later sessions and understand in deeper.
Can we draw an analogy of a class and an object for this?
Yeah, so if everyone knows about object-oriented programming or Java or C++, yeah, definitely I'll just go with the same kind of structure. Okay, so if you have a Java program, if you write a Python class and a Java class, the class is the image.
Okay, yeah.
So this class, when you write in the program, you're going to say object creation. So then you're going to say new. In the program, you're going to say new, then object will be created and it will be run in RAM. So when it runs into the RAM, then the object is ready to use. The program will be executing. The same thing, when it is running in a Docker container, the Docker environment is going to allow us to run this container. Container is like an object, and it will take what process you want to perform in that particular microservice. Okay, so when you are running a Tomcat is going to run Java application. So Java object will be created and Tomcat object will be like a container, it will be running. Okay, in a high level, your image is like a class and your containers are objects. So n number of objects you can create, and you need that much space available. If you have 4 GB of your Linux system, you can run 4 containers of Tomcat. You cannot go for 10. If you go for 10, what happens? It will block and it will crash. Containers will crash. So you have to think about the space when you're launching the instances of this Docker containers. Okay, hope you understood.
Absolutely, yeah. Thanks for the clarification.
Okay, so virtualization and containerization, this is one of the key points, one of the interview questions most of the time people ask, and we need to understand in detail. So when you go for VM, that is Oracle VirtualBox or VMware VirtualBox, what does it do? What is it is making? So it is completely making the complete stack from the bottom to top. It is going to create um, the disk. It is going to create virtual disk. It is going to create NIC. It is going to create the entire operating system kernel will be recreated. So this is wasting the memory and RAM and disk space. Whereas in containers, it will use the same kernel what you have Linux kernel inside your host machine. That is advantage, and so that you can have tiny size, smaller in size, and it is how it happens that we will discuss in detail. But in at the moment, this is a heavy, and the virtualization is heavy. Containerization is tiny and smaller, and no wastage will happen because it's a sharing. It uses the same space. Suppose you are using CentOS for Tomcat container, CentOS for the JFrog or Artifactory something, then the entire stack, what it is used operating system, that will be same layer. So that layers will be created in the image, and when you are running a container, the top one layer is a container. The only top layer will be recreated, and whenever you start accessing or running, bringing up the container, it will be very shorter in time. So boot time will be in virtual machine. When you do VirtualBox bringing up, it will take minute or minutes. Whereas in containers, it will be running in a fraction of seconds, milliseconds. Integration, when you integrate two virtual machines, it is costly because it takes the most of the resources. When you go to the containerization, it is very simple, easy, and scaling is so simple. You just tell that number scale equal to 4 containers will be created of the same type. So that is so simplified here, and each VM runs with own operating system. This is what the extra burden happening in the virtual machine. Whereas in containers, all containers share the host machine kernel. What Linux kernel you have, that capabilities are completely shared. And each one is going to isolate. Whenever a container is created, that is separate space. Okay, so that concept is we are going to get into when we talk about namespaces. Isolation of your containers, we can get it, that is automatically happen with the Docker. And when you're going to make this solution of that it works on my system, we need to pack. So packaging can be snapshot. It is going to have some versions. So when it is reusing the same thing, then it is again takes longer time to packaging. Whereas building the image incrementally you are increasing, it is just one layer extra added for one release to another release. Build releases, you're going to get, and you're going to do it on the pipeline on Jenkins and GitHub, whatever the code changes you are happening, accordingly you're going to tag them, change the versions. It is very simple and faster comparing with the network layers. So network virtualization, when you're going to work, virtual NIC card will be created, and its capability limited when you are going to work on virtualization. Whereas in Docker, it is completely under one umbrella or one gateway, and one Docker host machine, which you are going to take huge, bigger one, and you can run hundreds of containers in that one. That is the highest capability, and it is going to use one special network, bridge network we are going to call. So it is going to have one single entry point, and you can access, you can provide the access for the services which need to be accessible. Like front end, we are always go for the web applications, web servers, web containers. Next, it will come to the next level, that is database or some other critical data sensitive areas. Okay, so that is how we can differentiate between the virtualization and network containerization. Okay, So hope you understood. And if you have any question, let me know. No questions? Moving on. Okay, so what we will learn in today's course, prerequisites, what is required for this course and who can do this course. Prerequisites are you should have a laptop and you should have one of the cloud account and you should prepare one of the instance on that one. Okay, from that instance, we are going to do all the practices. Let's say you have a Azure account and then you are going to create a virtual machine. After virtual machine creation, and then it may be Ubuntu, it may be CentOS, any one of the Linux instance we are going to create. After that, we'll try to install Docker, how to install all those things. We'll try to work out in our course. So who can do anyone who is interested in DevOps and advanced learnings in that one, Docker, containerization, microservices creation, they can do. Docker concepts we are going to cover, and in this, how the Docker engine architecture, how it looks, and what are the parts, components are involved in the Docker execution. We'll also see how the deployment topologies are available in the Docker when you use Docker containerization, and also just have a high level understanding about Kubernetes concept, Kubernetes architecture we'll see, and then Kubernetes deployment process, what are the options we have. Okay, so that is about our today's agenda in high level. So if you see prerequisite, we have an idea about you should have SSH connectivity capabilities. If you are still working on Windows or something, then you should understand how SSH is working. So if you are used PuTTY, it is okay. And if you are already connected with one of the cloud, that is also very important. That will help on understanding how SSH works, SSH protocol works. Okay, every cloud instance is working with SSH connectivity. That is the first important thing. The CLA commands in terminal, how you are going to use. Okay, so when you're working on Docker, you don't need any credit card. But if you are working on AWS, GCP, Azure, there when you create the account, that time you have to create. Okay, in Docker Hub is one of the account we have to create. And that we have one of the capability called Play with Docker. So Play with Docker is one of the feature which is provided. You can create 3 instances or 5 instances, and you can make a cluster of those boxes, but very smaller in size. And the Linux is based on the Alpine Linux. Okay, so you should have good internet to connect with that cloud platforms, and then you can work on. So even you can work on laptop also if you have good RAM, at least 8 GB RAM and a good number of cores, then we can do practical in your local laptop also. Okay, so for that we should have Vagrant and VirtualBox should be installed on your system, then we can do that one. Better to have good headphones to hear clearly what I'm talking, and when you're speaking, that will be easy. So that is a prerequisite, Docker. So what is Docker introduction? We have already have, and then differences between these two applications types. Okay, monolithic application and container based, that is microservices. These are the two types of applications we are going to have in current market. The project which are a couple of years since before cloud, before microservices, what we have, that is monolithic applications. The same thing which is running in physical machine on Linux server, it is running on Tomcat. It may be Java application. But when they build, the developers build that application, that everything goes into one package. It may be .ear file, .var file, .jar file. So that will be huge. Okay, so every functionality is one particular function, but it is not a service in that monolithic application. Whereas containerization, everything is a service, and we are going to connect with one service with another service. Okay, so we'll see how it works and what is the difference between that. Images containers we have just seen And when we are working on Docker, we try to explore more about the Docker file, how to write the Docker file, and all those things we'll learn. And then Docker storage, that is volumes. We try to understand what is volume, how we can attach to a Docker container, that we'll learn in our course. And Docker networking, this is one of the important thing which will isolate from other networks. So it is, Docker is going to have its own private network. Whenever you create a network, it will be belongs to that particular project only. Okay, so Docker registry, we try to create private registry, and we also understand the public registry, that is Docker Hub. Okay, so Docker Compose is helps us to create multiple containers. Okay, at a time you're going to create 2 or 3 containers that is required to run one particular application. For example, web application talks to one of the proxy from the requests which are getting, then it at the back end you're going to have the database. Okay, so this is a common requirement for running the Docker. And we try to understand what are the best practices for the Docker. So this is the overall course content of Docker, what we are going to cover. And orchestration with Swarm also we are going to discuss in our Docker course. So let's see Docker orchestration, how it is going to work on Docker level architecture. So high level architecture. So when you have the intro, that time I told Linux kernel is required. So what is the purpose of that and how it is going to work? So Linux, from the Linux, Docker is borrowing this kernel creation. So it is going to run a daemon process, and this will become a server. And whatever the commands we are going to execute, it is going to use some resources and create them. Okay, it is manages different things. It is going to create images of Docker image objects, and Docker volumes, that is also one of the object. Um, and also we have, sorry, just a moment. Okay, if connection, if you disconnect, then again, please connect to the same link. Maybe in 5 minutes, it is going to disconnect. Okay, so going forward in this one, so the Docker container is going to run based on the Docker environment, Docker CLI command, what we are going to execute. So Docker CLI is one of the layer that will talk to REST API, that is a wrapper around the Docker server. So Docker engine, the Docker daemon are same. So Docker engine, Docker's daemon is going to take that command and try to create these Docker objects. Okay, it may be objects, it may be volumes, it may be containers, networks. So these are all different Docker objects which we can get it by executing some Docker command on the CLI. Okay, so the interaction and the process creation, everything is mediated by REST API. So Docker, whenever it is, when you type Docker command, it will takes the command and give it to the REST API. So whenever I'm saying REST API, it is going to use a protocol, HTTP protocol. Okay, so your Docker CLI can be in one machine, Docker daemon will be running in another machine. That is possible. You can communicate within the same network. Okay, suppose you are created one VM that is for Docker host, another VM you are created for Docker client. So this is what actually in real-time projects they are going to run for Kubernetes architecture. Okay, so every layer you can run in different. Yeah, every layer means only two things. One is client and another one is server. So in between, how it is going to work? That is the REST API. REST API will work with one protocol, that is HTTP. Okay, so now the communication is always secure, so HTTPS is required, and the communication between Docker CLI and Docker daemon, we are always using a secure communication. Encrypted data will be transferred from server to the client, both directions. So every time you create an instance of this, any one of them, image, container, volume, they are all hash SHA algorithm it is used, and it is going to create a identity for them. And when it is shifted or it is created, it is always uses the HTTPS protocol. Okay, so this is a high level architecture what we are going to have in Docker. Any questions?
Not for me. Thanks for this.
Okay, so going forward, and how this typically in real-time projects, how they are going to deploy and how to set up. If you're going to have one environment on GCP or on Azure or AWS, this type of architecture we're going to maintain. So there will be a registry. If you are going to see Azure, or if you're going to see AWS, AWS is maintaining ECR. ECR means registry. Okay, and even in public repository, you can say Docker Hub, that is going to have actual images. Okay, Docker images are present here. Let's say Ubuntu, CentOS, Nginx, Redis. These are all different images are available in the registry. So registry will be accessible with web access. Again, HTTP protocol in between everything. Okay, so mediating will be that one. So registry will have all the images, and your Docker host means your project where you want to run, their images you are going to download. So once this is available in your Docker host, this will become a Docker server. Okay, so Ubuntu, CentOS, Red Hat, whatever the images are required, you are going to pull, and that will be available here. Docker, where Docker daemon is running. This Docker daemon is giving access, or we are going to run the containers in this particular area. Okay, so this area is container space. So in the container, you can see different images. Okay, so this box, what you are seeing, that is a container. So these containers will be created based on the instruction given from the client, Docker client. So what instruction we are going to give? Docker build means it is going to create, it is ask the daemon, please create one new image. That is a Docker build command. So using these images you may create, or you want a customized image, you can make it. Coming to the Docker pull, you are already having some images. You are asking to bring into this Docker area, Docker host. Docker run will use one of the image and create the container. So like that, you have many options in Docker client. Okay, so all those Docker commands we are going to learn in our course, and that is a typical architecture which is required. And if you go for any cloud architecture, they are having a ready-made registry, ready-made Docker daemons. So these two things are already available. So we just need to use that one. EKS means Elastic Kubernetes Service. And when you are using that one, these containers will be used inside the cluster. And Elastic Container Service, ECS, that is AWS Elastic Container Service, ECS, we are going to call. Similarly, we have GCP also, we are having Azure also having the same kind of structure, but in a high level, how Docker will work. One registry should be there that will maintain all the images. One daemon should be running that is for the one particular project. In this project, I need only Ubuntu and Redis. That two images will be pulled and you are running with the containers. Okay, so that is how it is going to accessible, and everything we can do it from CLI and other build tools. So Docker images containers creation you are doing with some different programmings. Okay, so that is called a DSL, that is domain specific language, which we are having that one in Jenkins also. Same way, what is the status you want? Means you want this application is keep running, and that is a common requirement. When you run one Redis server, the Redis should be keep running. And when you're running that Redis, how many instances you want? I want 4 containers. You can just simply say scale 4 and it will bring that many containers. Okay, so this is how the Docker topology works. And yeah, in between to run this one, in between whatever the commands you are going to use, there you are going to use the different pipelines based on the build process you want to implement. So this is a topology which Docker allows us to work, client and server. Okay, image registry there and this thing. So if you don't have right now a registry, then we can use public registry, that is Docker hub.docker.com. All right. So there are two types of editions, Docker editions. One is commercial edition, another one is community edition. Commercial edition is enterprise edition, Docker enterprise edition. So if you want support from the Docker, yeah. So when you are having this Docker, first time when you start Docker, then you need to select which version you want to use and purpose, right? So first, whenever you start a project, you are going for POCs. So once they are successful, then we can go ahead for the higher, bigger level or a huge level. So Docker Community Edition help us to work with the small applications, and it is working. That is what we can check. But to run a huge application, enterprise level application, for example, you are going for a banking application you want to run into a Docker, or telecom project you want to run inside the microservices, then go for the enterprise edition. You may need some support, and at any point of time the business should be running. So that is the most common requirement, right? So enterprise edition is required when you have a bigger client base, and if you have just for testing purpose and learning purpose, go for the enterprise community and do that. So Docker C is freely available, open source, and we can use the Docker C for learning purpose. Hope you understood this bit difference between these two editions. Okay, so two things. One is definitely you are going to have more capabilities in the enterprise, and if you go for the free service, only limited services. So our container engine, how it works, orchestration and networking, security, all of them are available in our community edition. So enterprise edition is also having the same plus what you are having extra. So it is going to give certified infrastructure, means the images what you are downloading, they will certify official image, then only you have to download into your machines. It should not crash at any point of time. The next one is the image private registries you can maintain in Docker. There is a limit actually. So 5 team members can go and create one group team, and then they can work on the project. Once it is successful, then they can publish. Okay, so that is allowed in Docker registry when you are working on private registry. Container app management, the application management, sometimes the containers also help us to create mobile apps, iOS apps, and whatever the Windows also right now having the apps. So each one is growing in a different way. So that applications we can develop and run in the containers. That is allowed in the enterprise applications. Image security scanning capabilities we are having. That is one of the important right now. Hackers and the other people are trying to break this container concept and get into the application. So vulnerability scanning is most important thing. Code quality is important. So as we do in the application code program, whenever you develop Java program or Python program, you can scan that one using the Sonar Cube or something. So same thing is done by Docker. So Docker company will do whatever you develop your image, inside the image they will scan and try to check if there is something is wrong or issues, bugs, and give the report. That is the advantage you will get from the enterprise edition. Okay, so let us see one small demo so that you can understand how Docker works. Okay, so we can search Docker Lab and in Google and try to connect, and we'll see version, and then we'll say image, and then hello world. Anything is fine. One of the image and try to see. If you are already aware, that is fine. Otherwise, we'll see that. And I'll just go to my browser. Okay, so before going, you have any questions?
Not for me.
Okay. So lab play. So this is a common thing. So once you log into your Docker, sign up for the Docker, then you are allowed to do this sign up, directly connect. Otherwise, it will ask username password. Okay, so here, this is giving you 4 hours access for Docker engine. Okay, so you can play with that. And here, when you see here, Kinect symbol, so you can allow to create 3 managers, 2 workers, 5 managers, no workers, or 1 manager, 1 worker. So these are the different choices. You can create the Docker images, Docker machines. Okay, any one of them you can use the template. 3 templates are available. We can just directly go and see one instance also you can create, and you can see here. Okay, so once just click the add instance, it will be readily available and you can see that. Okay, so Docker version, if you're typing here, you are getting the 2 blocks. One is talks about client, another one is talks about server. Just now we discussed Docker engine and Docker client. Okay, so both are having different versions, wrappers, programming, etc. in the background. Docker is completely developed in Go language. Okay, so Go version you can also see here, and it is completely public repository, and you can also have the git commit. What is the last commit ID you can see here. Okay, so commit ID is present, and also tags whatever you have the version. So this version also available. Okay, so Docker version, exact version, what is the version? If you're going to say this one is a version. Okay, and if you want to run, just you can say Docker run command, Docker run, and hello-world. So whenever you said this Docker hello world, after that you got some output. Okay, so that output what we are getting, that is executed from the container. Okay, and it is first time it is checked in the local system. Is there any image available hello world? After that it is saying unable to find. After if it is not able to find, then it is trying to pull. It is trying to pull from Docker hub. So it is going to Docker hub and fetch that particular image. After that it is created the container. So once the container is created, download is completed, it creates a container, then you got the output from the container. It prints just like in Python program or shell program, you're going to say echo. So this message is going to be displayed. Okay, this entire thing is displayed. So how we can run the command docker run -it and ubuntu bash. This is one of the example it is saying. So you can just simply copy and paste so that you can enter into this one ubuntu instance. So if you are going to say here ubuntu, it is first checking latest version is available in my local system. If it is not, then what happens? It tried to check. If it is not, then it is fetching from the Docker hub. After fetching that, it created another container. Ubuntu container is created, and you now you are out of this host. What you are right now, 192.168.0.18. It went inside the container now. So entering into the container is like this. Okay, so how we have met, you just check the image and you are saying bash. So when you said bash, it is entered inside that one. So you entered inside the bash, and the shell connected. Any command you can run actually. So ubuntu, sorry, there is a network problem. Are you guys able to see my screen? Are you with me?
Yes.
Okay.
Yeah.
So you can create instance at any point of time, and this connection is available for 4 hours. Okay, so I think this, yeah, we got that. So Docker commands we can check, and we can see Docker version, and we have seen Docker version. So if you are giving hyphen version, sorry, double hyphen. Okay. So it will give exactly what version you are having, Docker version. Okay. So are you able to see my screen at the bottom? Maybe this is better. Okay. So this is going to give you the version, and another command which will help us to Docker is running or not, that is Docker info. So it is going to give whether this Docker is running with some volumes, what kind of volumes it is using, which one you are configured. All the information is available, and how many containers are running in this one, that is also you can see. Okay. So if I'm going to run a Docker container, we can simply say Docker run hello world. Okay. So it will try to fetch and try to give the hello world. This is what we have tested. And how we can see how many containers are available. Just same previous command you can run Docker info, right? In this Docker info, you can see count stopped container is there. You can see here in the server, I have a container, but it is stopped state. And the same thing you can also check with the some other command Docker images. If you are going to say, I have hello world. Okay. So if I'm going to run the same what is instructed here, Docker run command to get inside this Ubuntu container, means two images are there, two containers will be there. Okay. So right now I'm inside this Ubuntu. I cannot see what are the images. I cannot run the Docker command. Okay. If I'm going to say Docker info, it will not work because I am inside the container. How I can say it is inside? You can see at the rate what you are getting. This is the image what you are created. Okay. So sorry, the container ID is here. Okay. So exit from this one, and that Ubuntu will stop. Okay. So when you enter inside, it will be waiting for your commands. It will execute the commands. When you are come out, then it is closed. Okay. So Docker PS will help us how many containers are running. Okay. Right now, no container is running. If you want to see how many containers are stopped, you can simply say A, then it will show exited state. The status you can see in this column, and you can see image. So we have used Ubuntu, we have used hello world. You name the server software and you will get the images available. So how do we know this software is available in Docker or not? Okay. So Docker, let's say I want to search for Tomcat. Search Tomcat. So you have a lot of images, and there is one specific thing. When you are downloading, you should be look for this one, automated and official. These are the two things which are important, and stars also important. One, how many people are downloaded, they are going to give some stars. They are members in the Docker hub, and they are going to give the stars. So more stars, more accurate, more safer. Okay. That is what you can do. So if you are going to say Tomcat, Docker run Tomcat, simply if you run, it is first trying to download, but it is having number of layers. Okay. One of the layer may be Ubuntu layer, one of the layer may be CentOS first platform. After that, it is going to have Java installed. After that, next layer, next layer, next layer. So some number of layers are pulled. After that, the complete that container done. So each image you can search in Google, and you can see uh, the image is going to have some information about it, how to run. Okay. So Docker Tomcat image, if you are going to search, you are going to have the Tomcat official image information. And if you click that one, you will be having information how to pull first in the right side. Image will be pulled, but how you want to run, that is your own choices. Okay, and these instructions are very helpful when you're running your Tomcat, when you're running Jenkins, all those things. Okay, so yeah, so that is about different versions how we can run. So run command, most of them they will give. Suppose you want to run Tomcat 9.0, this is the way you can run. Okay, so run instruction is a common thing which is required, that is given. And Tomcat, how many versions are available, where we can see that is available in the quick references. We can see here it is maintaining a separate community actually. Who want what, they can look into that one. And yeah, these are all different links, and we can use them as a Tomcat. After that, this you can use as per your platform. And hello,
Yep.
Maheshwari. So which version of Java you want to use, that is also one of the key thing which makes the images. So if you want to use a Tomcat 9 version and JRE 8, that is a combination, then you can find here image tags. Okay, tag will be always used after the image name. Okay, when you want to pull the image, what is command you're getting, that one, this is a common command. But this image, for example, you are going to use JRE 8, the pull command is here, Tomcat : then tag name. Okay, what is its capability, that is given here. All right, so that depends on the Linux. Some dependencies like Java and what platform you are using. You want to use in CentOS or Ubuntu. These are all different capabilities. You want to go for JDK 17 or JDK 11, Linux. So these are all different requirements for the running the server. Okay, yeah. So how we can run that image we have seen, and what else we have? We'll say. Okay, sorry. Docker run will say. Okay, it says right now it is not available. Previously it was one of the image available, and it will be showing that. All right. Okay. So hope you understood how to run Hello World. You have already seen, and then yeah. So I can just give you a high-level intro of Kubernetes at the moment, but yeah, out of time, we can see that in the next part of demos. So hope you understood how Docker is working. What is Docker? Who are interested, we can have registrations with Shailaja, and please talk to her, and we can proceed on that one. So the classes will be at the same time, 6:30 morning AM India time, and it may go around 1.5 hours every day.
All right. Thank you, Bhavani. Yep.
Yeah. Thank you, guys. Thank you, everyone.
Thank you. Yep.
Bye.